So we'll be doing our tutorial class today, continuing from the lecture. So I demonstrated you how to do the regression analysis in R with simple linear regression. So now I'll continue doing multiple linear regression. So let me share my screen with you. Share a screen. And let us go to our R. Okay, since it is the tutorial class, so what I'll do, I'll repeat from the simple linear regression analysis. So in today's tutorial class, I'll be discussing mainly three important analysis. One is the regression analysis in R. I'll cover both simple linear regression when we have only one predictor, and then multiple linear regression when we have more than one predictors. Then I'll discuss principal component analysis, which is the method of data reduction. And then I will show how to do cluster analysis in R. So cluster analysis is used to group the data into homogeneous groups. So let us start with regression analysis. So let us do regression analysis. So first thing I'll do simple linear regression analysis, simple linear regression analysis. So in the first step is really to read the data. So we have created a data file called data.ra1.csv. So it has two variables. One is the X variable, another is the Y variable. So first step would be to read the data. So I'll call it data1. So data1 equal read.csv.
Excuse me, sir.
Yes.
Sorry to interrupt you. Sir, I have sent you an email regarding the quiz. Please, sir, can you check the email?
I'll do, yeah. Not now, later on.
Actually, like, about my quiz, because this class is with another quiz.
Oh, that's right. So you said that. So I'll send, yeah, I'll give you the time to do the quiz. So after the tutorial class, okay?
Okay, sir. No worries. Thank you,
Because
sir.
you should not miss this tutorial class.
All right, sir.
So data1 equals read.csv. And then we have to give the name of the data file. So data file is our data1.csv. And header equals true. So that is the first thing we have to do, that data on, which is our data file that we'll be using for regression analysis. Then reading CSV file, and we created this data1.csv in Excel before, and it is available in my folder there. And then comma header equals true.
As I can remember, your CSV data file name is data regression 1, something like that.
I think you are right. That's right. So data1, we want to create it. So basically, I think you are right. So it is data RA1. So it's data RA1.csv. So now it looks all right. So So we can really look at the data one. We generally use the command attach data one, and then we can look at the names of the variables in our data one. Just to check the data, always data has to be correct. And we can look at the code, and we can really SOLID, solid RED reduction. We can do a plot of the data just to see. These are the things that's not important, but it's just to visualize the data. So COD, SOLID, solid reduction. So that will give the plot of the data. So we are now sure that the data is correct. So before we do any analysis, we have to make sure that data is correct and reading the data correctly. So as I mentioned, like we have to upload some packages. So you have to go to load packages, and we have to always use the some thing here, which is Canberra or something, but already I did that. So you already linked there, and then we have to download two files. One is the MASS and ISLR from this list of the packages. So I did that already. So then we have to write require. So I'll write a command here. Okay, so I'll write a command here, just a comment. Download two packages. What are these two packages? One is MASS and ISLR. Okay, so what I'll do now, basically, I want to copy this part as a screenshot, and I want to save it in a folder so that I can send it to, I can put that in the views. So what I am doing is here is I am doing a sniping, and really I want to snipe all of this. And then I want to create a Word file. And I put it there so that I can put that in your views so that you can have a look to this. Otherwise, I know you will not be able to remember everything or able to write anything. So you download these two packages, and then we type it require these two packages, MASS, and also require ISLR. And then we say lm.fit, linear model.fit equals lm. And then our y variable is SOLID reduction. And then we use this tilt variable. And then our COD. So solid reduction is y equals x, and then data. So data is our data one, because we have created data one for this. So lm fit equals lm solid reduction RED, and then COD as a function of that, comma, data. So I look, it seems all right to me. So we put it the command, and then basically our model is done. So now I can get the summary of the model. So summary of the regression model, which is lm.fit of our model, that which is the fitted model. You want to see the summary of the model. So now you see you have the summary of the model. So again, I will snipe this again so that we can have a record of it in our port file. So sniping tool. So new sniping, and so I'll just, I think you can do it from here. If there's some repetition, not a problem. Okay, so that let me save this file before we miss it. So we'll be saving it somewhere. More saving options. So I'll go to, let me see, quiz to repeat is not a good place for me. Okay. Documents. Statistical hydrology, and then 2020 on, and it's the our notes for students, and our lesson 6 regression analysis. So regression analysis in R note by
Sorry, sir, your screen is not changing.
you don't have to look at that thing, probably save. Just what's happening? Please read window away from the shared application. Okay, what's happening? Okay, so anyway, I have saved that there. So can you see the R window here? The word window. So you have to save in R. Basically, you have to go to R. Okay, so can you see the R window now?
Yes.
Okay, that's right. So I just saved that in Word file, which you don't have to see. So we can see from here that the regression is our, the model is there, like our coefficient here. So the model, we'll write the model in the way that we can write our model here, which is our data is our solidity reduction. So our model, we can write the model here. So we can say model is like the solid reduction equals, what is our intercept is minus 0.95651, and then our 1.029 times is COD. So that is our model. So we can write that model there. So we have got the summary of the model, and you can see that the COD is highly significant because its T value is very, very small, smaller than 0.1. So it is highly significant. So we can get the confidence interval of the coefficient. So we can say CONF int LM dot fit. We can get the confidence interval of the coefficients there, and then we can put an AB line on the our scattered data point LMFIT.
So, sorry, sir, before doing AB line, should we do the plot first?
We have done the plot, I think, already in the screen.
Oh, yeah, yeah.
We have done the plot, but really, I think that's a good idea to do. I think that command should be here, I guess. Plot COD dot SOLID reduction. So it's a good idea to make that plot. So that plot has been done twice. So anyway, that's fine. So now we want to do that AB line LM dot fit. So that is our regression line, fitted line on the point, and we can see there is some scatter, which is that's why our R square here is 0.9129. So there is a 10% kind of variance there unexplained. So that's why. So we can get all the regression diagnostic plots. So we can say here plotting the diagnostic plots, regression DIAG NOSDIC diagnostic plots. So you can see that I am putting a number line like this. That means that it is a text, and it becomes so plotting the regression diagnostic plots. So how we do it? We do first we create the one thing is that we can change the color of the plot and the thickness of the line by again by AB line with the command that lm dot fit LWD is the thickness of the line, comma color equals red red. So by that way, you will change the color of that line. And now we want to do 2 by 2 plots, the 4 plots in one column. So how do we say? For M F row equals C 2 by 2. And then we say, probably I will remove this one first. And then I'll say plot LM dot fit. So it has produced 4 plots basically in 4 lines. So basically we want, so it has not been affected. So MF row C22. So let us again repeat that. Okay. And then I want to repeat it again, the plot, and see what happens. Okay, now the 4 plots in one screen really here. So basically, this is all about linear regression analysis. So I want to copy it. I think we did up to that before. So we need I need to screenshot of this part. So I just do a screenshot of this. I think probably we have not copied some part of it before. I think I copied. We did copy this and okay. So I think I did not copy from LM fit. So let's do the sniping from there. New sniping. So So basically from here. So Control C. Okay, so I think we have finished the simple linear regression analysis. Now we'll go to multiple linear regression. So multiple linear regression is really our data set has more predictors there. So I think it might be a good idea to show you the data first in Excel. And because that will give you some good idea about the data. So our multiple linear regression data. Okay, so let me stop share that R and then I share you with the this one here. So can you see my Excel file here?
Yes, sir.
So you can see here that my station ID and then I have the Q 10% AEP flooding quantile estimated by analyzing annual maximum flood data at each of these sites by LP3 distribution. These are done by LP3 distribution. And then we have variable area I650, MAR, mean annual rainfall, SF is the shape factor, MAE, the mean annual evapotranspiration, SDEN is the stream density, MSL is the main stream slope, and main stream slope, and S1085 is also the slope. So MSL, stream density, and then we have the shape factor there, evaluation MSL. Okay, so this is the predictor variable. What is that MSL? Anyway, that's the predictor variable. So I am not sure how we have abbreviated it. Probably have to go back, but I don't care at this moment because I want to show the regression. So stop share, and then I'm going to R again, and then we'll read that data basically. So now let us do our multiple linear regression analysis. So MULTIP multiple LI linear regression analysis. Multiple linear regression. So multiple linear regression analysis. So first thing is that we have to read the data. So I call it data2, and our data file that I already created there, read.csv.
Sorry, sir, I cannot see your screen.
Okay. So yeah. So always tell that it's share screen. Okay. Can you see the screen?
Yeah, it's okay now.
Okay, so we have to we are doing multiple linear regression analysis. Data2 equals read.csv, and my data was, I gave the name ML multiple linear regression dat dot csv, and then HIDA equals true. So that's basically I read the data, and we can really check the data too. How is the data too? So we say at us data two, and we want to say the names of data two. So you see that really estimate SID and then all the predictor Q10P, they are Y variable, and our X variables are all the variables after that. So that is our data. If we want to see the data 2 itself, still we can see that, but I am not going to do that. So that is really the data file. Now we want to do the linear fit, lm.fit equals lm, and we have to write our Q10P is our Y variable, and then what are our X variable here? Our X variable is our area, and then we have to put plus all of them, I650 plus MAR plus SF plus MAE plus SDEN plus MSL plus S10 85 S10 85. So you have to make sure all the variable names are correct. lm.fit because Q10P, which I can see is correct. Then area I650 MAR plus SF plus MAE plus SDEN plus MSL and SDEN 85. L and 1, is it same looking? They look same. Yeah. Okay, so that is my regression done. Now we'll put summary of our LM fit. Enter. So that is, we can see that the regression summary, this is important analysis things here. So we can see here that our for our p-value of the variables for area is 0.99, so it's not important. Rainfall I650.101 close to R, close to 10%, which we can keep it. And we see the other variable MSL is coming as pretty important. So only 2 predictors are really significant. So we can repeat our regression with using only those 2. But in many cases, we can keep all the variables as well. So that is a summary of the regression. These are the coefficients here. And these are the standard of the coefficient, the t-value from the t-distribution. So basically, we want to keep a record of that in our odd file. So what I'll do, so multiple linear regression. So I'll do the screen save again. So sniping tool, new, and I'm really taking from here that multiple linear regression. And maybe I do first screen is this. Control C. So I'll go to my Word document here again. Okay, so multiple linear regression analysis. Multiple linear regression analysis here. And then I have part of it. So I go to R again. So then we do again another sniping. sniping again. So it's a new sniping. So now basically I did up to there before. So I want to do it more now. So these are the Control C. I come to the Word document and put it here again. Okay, so you have come here. So you have done the summary of the linear fit there. And we can plot our regression plot. So we just say PAR MFROW. We did that before, but I'm repeating it here again. See 2 by 2 for plots. And then we plot the LM dot fit. So it has given 4 separate plots, but we want in same plot. So let me repeat the procedure again. Okay, so now we have the 4 plots in on diagram, and really this gives you the diagnostic plots, and it really tells you how well the regression done. These are looks quite poor in my opinion. So because we should have done the log of the data, then it will be better model. So that is basically the multiple linear regression analysis. So basically I will take this part again as a sniping. To new Control C. Okay, so do you have any question on regression analysis? Okay, I'll now go to the principal component analysis. So basically, I'll do now principal component analysis.
Sorry, sir, as you mentioned earlier, like from this model, we can see that the I650 and MSL is significant at 10% level of significance. So should we consider for further analysis only these 2 variables?
That can be done as well. So we can do another regression analysis with only 2 variables. But in this case, the best thing would be to convert the data into log transformation for the dependent and independent variable. And if we do the regression, that would be much better. So, but I'm not doing it because that can be done anyway. You can do it.
Okay. Okay. Thank you, sir.
Because I want to finish other things, you know.
Okay. Thank you, sir.
So principal component analysis. I will show how to do it. Principal component analysis for this. I have to change my directory because first read the data. First read the data, and then we do the change directory and locate your folder where is the data for PCA. So PCA data, I'll show you first. I'll show you the PCA data in Excel. that will give you some idea of what we are trying to do. So I'll go to our lesson 7, principal component analysis. So principal component data. So okay, so this is our, so let me share the screen with you. Okay, so just give me a moment. Okay, so share a screen with you again. So you can see that the data is here, is it right? So we have our variable area, I650 rainfall intensity, 6-hour duration, 50% AEP, mean annual rainfall, MAR, SF is the shape factor, MAE the mean annual evapotranspiration, SDEN is the stream density, MSL is the main stream length. Last time I think I forgot it, a main stream length. And S1085 is the slope of the main stream at 10% and 85% length. Okay, so this is the data that we will be using in R. We have to save it in CSV file, ms.csv file. So now I am going to R again to do our, so first thing is that we have to change our directory. So file, go to change directory and then documents. Statistical hydrology is here, and then statistical hydrology under 2020 on, and then our notes for students, and then lesson 7 is our principal component analysis data is here. So I just located my directory to the correct location. So that's done now. So now I will tell it that really my data 3, I'll call it data 3. You can give any name, it doesn't matter. Read.csv. And my data file is there, PCA, principal component analysis dat .csv. That is my data file, that is the name that I have given. You can give any name if you like, it doesn't matter. So data 3 read CSV, PCA dat.csv, header T. I think. Okay, so that is the data. So we can look at the names of the data in my file. So names, first let us do address, ATTACH address, or data 3. Then we can say names of data 3. So this is our variable names here. We don't have any dependent variable here. When you do the principal component analysis and cluster analysis, you only use the predictor variables. So that is really the thing for reading the data correctly. And now we can do the principal component analysis by this command pr.out. That is the command you have to write, pr.out equals, this is the function pr comp, principal component. And then our data is our data 3. And scale is TRUE, scaling we have to do. So that is our principal component analysis. So that is principal component analysis is done. So then if we want to see the results of the principal component analysis, then we can type different commands. First is the names, here.out, what are the things they are in that output. So you can see that is giving the standard deviation, rotation, center, scale, X value. So that's the, and then we can look at the different thing by PR dot out, and then we can say $CNTER. So it means that from that data file, I'm trying to see what is my center values there. So I can write, see the center values there. And if we want to see the scale, then basically we have to write from that file a scale, SCALE scale. So let me take a screenshot of this and put that in our sniping tool, new. So principal component analysis, let us take up to here, Control C. Let us go to our raw file. I see principal component analysis, and then I put this on here. So I come to the R again. Okay. So I have got the scale, and also I can get the rotation as well. So basically go to rotation, ROTATION, rotation. So these are basically the principal components with the different variables there. Then finally we can do a biplot, which is very, very important. Biplot is PR dot out, comma SCL scale equals 0. So this biplot is very important. You can see here that your biplot is giving the different variables and their importance. Like the longer the arrow, the more important is that variable in principal component analysis. So really, this is very important to identify which variable is more important for the data. So these are the different things that we are taking the output of the let me see how far did I copy in my old file. We copied up to a scale. So we copied up to a scale. So we can copy now up to some more we can copy. So sniping tool, new sniping. So we did up to scale. So we want to do now rotation and the biplot. Control C. So I'm coming to here. Okay, so we got the we have done the biplot, and then we can look at the other results of the principal component analysis. PR dot variance equals PR dot OUT, and then we can say $SDV and square of that. So that will give us the variance principal components, and we can look at that PR dot B variance there. So this is the variance of that, and then we can find out
Sorry, sir.
PRE.
Can I just quick comment?
Sure.
So, the variance is ordered as per the variable ordered name.
No. That's according to importance of the principal components.
So PC1, PC2 up to PC8.
That's right. Yeah. We are coming to that point finally. So we are doing a step-by-step calculation. So in R, you can do a lot of calculation within the screen itself. So some, and most of the time you create a function so that it does everything for you at one command. But here I am showing one by one so that we understand what we are doing. So this is our so this is really the variance explained by the principal component. So basically, the result is telling that. So we write a comment that the above result tells that PC1 accounts for 49.73% of the variance of the data. So that is the variance of the data explained by the principal components. And we can do some plots of this data. So what we can do is that we can do a plot of the ERE X lab equals, so x-axis level principal components, COMPONENT, principal component. So that is our x level, and our y level, axis of the level of y axis is our proportion of variance explained. Proportion of variance explained. So that is our y things, and I think it's y limit equals C of 0 to 1, and then TYP type equals B. This is all inbuilt things in R. I have to confirm one thing, that is y limit. Just let me check my book. That thing I have, but sometimes handwriting is not easy to understand. Sometimes my handwriting is not that good. So
Here on type, P is quoted by one is single, one is double.
sorry.
So last word, the type equal B.
Yeah, that's right. There's a
quoted-
typo. Thanks for that. So there's a typo there. That's right. Thanks for that telling me. So let me check on command. I have confusion for that one. So let me check the book classification. Since I cannot find it quickly. Anyway, let us see how it works. So I think it probably worked. Let me see. So we have done one thing wrong is that Ali Ahmad found is that this. Okay. So let us check it. Principal components, I think it probably works. Yeah. So this is the script plot. This is, we call this plot as the script plot. So we just say that the above command creates our script plot. So the above command prepares a SCR script plot. SCR script plot. Okay, so that was the limit. So y limit. So that was the y limit. So y line m. Okay, so let me again snipe it. So we did up to by plot. So we do up to here. Control C, and we go to the Word document where we have the.
So are you taking attendance?
Yes.
We'll take the attendance here. I think Gokul is taking the attendance.
Yeah,
Let me,
yeah, I'm doing. Yes,
let
yes.
me
sir.
put.
Praise off.
Yeah, just I am coming. So can you see now the screen?
Not yet, sir. The recording stopped.
Connected to computer audio. So probably I have to share a screen again, probably. So our ID for the tube class is 245. So, okay. 245 is already there, so I have to share a screen again, I guess. Screen. So can you see my screen now?
Yes, sir.
Okay, so that's good. So okay, so let us snipe these two figures from here as well. So these are the two figures that we want to snipe. Come to the big storm here. Okay, so these are the type of plot that it produces from the type of commands. So I put it here. That's a good thing. And then we come to the R again. Okay, so that is all about principal component analysis, I guess.
Sir, we cannot hear you.
So can you hear me now?
Yes, sir.
Okay, so there are some power problem because the storm is going on. So now we'll be doing the cluster analysis. So that is the final thing we want to do today, cluster analysis. Cluster analysis. So for cluster analysis, we have is kind of data file there. This is we say this is data 3. So basically, so the same data we'll be using for cluster analysis. So first we read the data. So same command as before that when you read the data. So this is the data 3 basically. So we'll do the same thing, data 3 equals read.csv. The same data as before that we'll be using the same data for cluster analysis. CSV. The data is already here, but I am typing because if you want to start by yourself. So this is by the data here.
Shared, sir?
Or I am not showing you.
The screen is not visible.
Okay, so we are doing cluster analysis. So this is the same data we are using. So basically I am calling it data 3 as before. So data 3. So one thing is that what we can do is.
Can you hear me, sir?
Yes, I can hear you. You cannot hear. Okay. What's going on?
Sir, your screen is not
Yeah.
shared.
Because the big storm is happening here. That's this kind of causing connection problem. So now is it okay?
So no, sir, screen is not visible yet.
So can you see the screen now?
Yes, sir.
Okay, so now it's probably good. I think it's giving a lot of disruption due to the some big storm is happening at this moment. So what we can do that our data 3, we can just we want to scale the data before cluster analysis. So what I'll do, I'll say that my x data is data 3. Of course, we have to do before all the time as before attach data 3 and then names of data 3. That we always do as before. So these are the variable here. So for simplification, just I can say my x equal data 3 so that I don't have to type data 3 because I want to do the scaling of the data. So what I will say, my x data, which is scaled, which we scale command scale of x. So it means that my x matrix will be scaled. Okay. So now really we can really now do the analysis. So we can look at the dimension of the matrix of XSC